Hi everyone, so this video is going to take us through the first of the algebraic methods that we're going to look at this year for solving simultaneous equations. So the advantage with an algebraic method is a couple of ones actually. First, you don't need any graph paper. You don't need to worry about being super precise with your ruler and with your graphing to make sure that you're going to get your answers correct. And it's going to be way better for any of the solutions that would be a fraction. So the first of the three methods we're going to look at is sort of one half of one method. So this method is applicable in particular when you have two equations that are both written as y equals. So you'll notice that the header is solution by equating values of y. So remember, when you are solving simultaneous equations, you're looking for the one combination of x and y that will work for both of these equations. So if both of the equations are written as y equals, then both of those values of y are going to be the same, right? We're looking for the same value of x and y that works for the first equation that also works for the second equation. So if those two y's are equal to each other, then that means that what those y's are equal to, i.e. in this case 2x minus 1 and x plus 3, those must also be equal to each other. And that's the key that unlocks this method. If the y's are equal, then what the y's are equal to must also be equal. So if we know that, then we can set up an equation for ourselves to solve where we take what the first y is equal to and set it equal to what the second y is equal to. So this y is here and that y is there. We know that those y's must be the same. So what those y's are equal to must also be the same. And then at this point, this is just a linear equation that we need to solve. So thinking back to all of our rules for solving equations, we expand any brackets that we have, we get all the x's, all the unknowns on one side, and then we isolate to solve for what that unknown is equal to. So let's go ahead and do that. So step one, for this one, I'm going to subtract away that x from both sides. So that gives us 2x minus x is just a single x, minus 1 equals 3. And then the next thing we're going to do is add 1 to both sides so that we get x entirely by itself. So we get x is equal to 4. So now that we've worked out what x is equal to, then we have to go ahead and work out what y is equal to, because we need that combination, the x-y combination that will work for both of these equations. So we figured out what x is, now we figure out what y is. So what we're going to do is take this x value and we're going to plug it into one of our original equations. Done correctly, and I'll show that out in a moment, done correctly, both of these will give you the same answer. So you just need to pick the one that to you looks the easiest, and that might be a different choice for a different person. For me, I like the look of that second one better. X plus 3 to me is an easier equation to solve than 2x minus 1. It's got one less step. So we take that equation, y equals x plus 3. We replace the value of x with what we just figured out x to be, which is 4. So we're going to make that y equals, replace x with 4, and then plus 3, so we get a final answer of y equals 7. So our ultimate final answer, x equals 4, y equals 7. So if we had graphed that, the coordinates of the point where the two lines cross would be 4, 7. An x coordinate of 4, a y coordinate of 7. So let's say that you liked the look of the first equation better. So you decided instead of doing y equals x plus 3, you are going to do y equals 2x minus 1. So you replace your x with what you figured out x to be, which is 4, and then you're going to solve. So y equals, that becomes 8 minus 1, y equals 7. So look at that. It didn't matter which of the equations we used to solve for our y value. Both of them will give you the same answer. That's the whole point. It's the one combination of x and y that works for both of these equations. So that is the first method of solving simultaneous equations algebraically.